Arc length and sector area are the same idea dressed in two costumes. Both start with a fraction of the full circle. If you master the fraction first, the formulas stop feeling like memorization and start feeling like common sense. Degrees are the default on most items unless the problem explicitly switches to radians. Let theta be the central angle in degrees. The fraction of the circle inside the sector is theta divided by 360. Arc length is that fraction times the full circumference, 2πr. Sector area is the same fraction times the full area, πr squared. Notice the parallel structure. Same fraction, different whole, circumference versus area. Before you plug in numbers, circle the radius. Radius and diameter are not interchangeable in these formulas. Easy example. A 90-degree sector in a circle of radius 6. 90 over 360 is 1/4. Picture 1/4 of a disk. The curved part is 1/4 of the circumference. Arc length is 1/4 times 2π times 6, which simplifies to 3π. 90 degrees is 1/4 of 360, so you should picture a quarter slice of a disk every time you see a right angle in a circle. Sector area is 1/4 times π times 36, which is 9π. Medium style, they give you arc length and radius, and you solve for the central angle. Suppose the radius is 5 and the arc length is 7p over 3. Write the fraction theta over 360 times 2πr. Substitute s and r, you get 7π over 3 equals theta over 360 times 10π. Isolate the fraction theta over 360 before you chase big products. It keeps the algebra readable. Cancel pi, multiply both sides by 360. You will find theta equals 84 degrees. Harder style, they want the shaded region between an arc and the two radii, but not the triangular part in the middle. Compute the sector area with theta over 360 times πr squared. Then subtract the area of the triangle, formed by the two radii and the chord. For two radii, an included angle theta. That triangle area is 1/2 r squared sine theta. On the SAT, theta is usually nice, so Sine and the geometry stay manageable if you stay organized. You are removing the straight-sided triangle between the two radii, not the curved arc itself. If the problem uses radians, arc length is r theta, and sector area is 1/2 r squared theta, with theta measured in radians. Common mistake, you plug the diameter into πr squared or 2πr and you forget to have it to the radius. Circle the words radius and diameter in the prompt. Underline r before you compute anything. SAT tip, always find the fraction theta over 360 first. Decide whether you are taking that fraction of the circumference or that fraction of the area. Recap, the sector area and arc length share the same fraction of the circle. Arc length uses circumference. Sector area uses the full disk area. For shaded regions, subtract the triangle when the problem asks for the curved segment only. Practice more on NovaMaths.